So welcome back, and we're on page 6, and we're going to dive straight back into our study of finances. So here's an example, and it's a really important idea, is that when we solve for n, remember that n doesn't mean the number of years, n is the number of time periods. Okay, so we're just going to do a couple of examples just to highlight this. A woman invests 1,000 Rand. Her money earns 8% interest compounded annually. After how long will she have 1,800 Rand? So the first thing is we must make sure we use the right formula. A equals P 1 plus I to the power of n. That's our compound interest formula. We want our A value to be 1,800. We want our P value to be 1,000. The interest rate is 8%, which is, remember, 0,08. We need to divide that by 12, and then we're going to say n. Now, n is going to be the number of months. Okay, there's only one variable left here, and that is n. So let's just divide both sides by 1,000, and we get 1,8. Over here, we get 1 plus 0,08 over 12 to the power of n. When we're solving an equation and the variable is in the exponent, we use the log function. So n will actually be log base 1 plus 0,08 over 12 of 1,8. Right, really important that we sort of keep our handwriting as neat as possible, so we've got everything sort of on the right level. And let's take a look at this. So log base 1 plus 0,08 over 12 and of 1,8. And we get 88,46, so 88 and a half, right? That's months. Okay, let's round it to the nearest month. Okay, so 88 months. Right, now 88 months, the question asks us to express it in months and years. 88 months. 12 goes into 88 6 times, all right? In fact, 12 goes into 88 13 times. 12 goes into 88 6 times. 12 goes into 88 7 times. That's actually 7 years. 7 years is 7 times 12 is 84. 7 years and 4 months. Right, we're going to ask you to pause the video and try the next one, and then let it play again and see how you went. Okay, how long will it take for something to double? All right, how many weeks? Okay, how long will it take if the money is compounded weekly? So here's our formula. A equals P 1 plus I to the power of n. Now, we want P to become 2P. We want it to become twice as big. We could let P be 1 Rand, in which case we'd have 2 Rand over here. We could let P be 7 Rand, in which case we'd have 14 Rand over here. It really doesn't matter. We'll see now that the P will divide out anyway. Now, our interest rate is 0,12, but we're going to divide by 365. No, not by 365, not daily. Weekly, we're going to divide by 52. All right, and then we're going to raise this to the power of n. And this number here is the number of weeks. Okay, so now we're going to divide both sides by p, and notice we just get 2. All right, so now we've got 1 plus 0,12 over 52 to the power of n. And exactly as last time, we're going to use our log function. N will be log base 1 plus 0,12 over 52 of 2, and let's see what that comes to. Right, it comes to 300,7, so about 301 weeks. 301 weeks, and again we could convert that into years. All right, remember there are 52 weeks in a year, so it's almost 6 years. It's a little bit short of 6 years. Here's a useful little rule of thumb, right, which we just share with you for interest, okay? And that is that money doubles when invested at 8% for n years when the product of the interest rate and the number of years equals 72. So for example, if we've got 12 years, then money will double at 6% per annum, because 12 times 6 gives us 72. If I'm only going to earn 8% per annum, all right, then 72 divided by 8 is 9. That's how long my money will take to double. That's not exact, but it's a very useful rule of thumb. It's called the rule of 72. Right, just it's a good thing to remember, just to sort of sense check your answer. All right, it doesn't replace the need to use the formula, but it is helpful. It also helps you sort of show off in front of your friends. If someone says, "Oh, I managed to double my money in sort of 12 years," you can say, "Oh, well, that's actually only 6% per annum." Or if they doubled their money in 6 years, you say, "Oh, it's 12% per annum. That's a great investment." Okay, right. Now, we're going to talk about what are called nominal and effective rates. When we give an interest rate with a compounding period, like that, that's called a nominal rate. Right? And we write it in symbols as I with a little power of 4 in brackets equals 12% per annum. And what it means is that you'll receive 12% interest over the year, but your interest will be calculated 4 times per year, 3% each time. So you're not going to get 12% every quarter, unfortunately. You're going to get a quarter of 12% every quarter. The result will be higher than 12%. Okay? And is called the effective rate. Now let's just understand why we will end up getting more than 12% effectively. If we, instead of getting 12% at the end of the year, if we get 3% at the end of the first quarter, we've now got a tiny little bit of interest. And in the next quarters of the year, that interest will earn interest. And that's why 12% compounded 4 times a year is better than 12% compounded once at the end of the year. The effective rate is the net effect of the interest over 1 year. All right? And effective rates are always higher than nominal rates. So we're going to do a couple of examples. We're going to do a couple of examples just to show you how this works. Now, some people learn kind of a fancy formula. I don't recommend that you bother with a fancy formula. I recommend that you just think about investing R1 for 1 year. R1 for 1 year. And the only formula we're going to need is this one. And this formula does get provided to us. It's our normal compound interest formula. Okay, right, let's have a look. So what I'm going to do here, I'm going to underline this in blue. 10% per annum compounded monthly. That's a nominal rate. And I'm going to underline this in red. That's our effective annual rate. And what we're going to do, we're going to make an equation. So equal sign. And on the left-hand side with the blue pen, I'm going to do how much money would I get if I invested R1 like this. So it would be R1, 1 plus P is R1, 1 plus I, my interest rate is 10%, that's 0.1, but I'm going to divide it by 12, and in the year, there are 12 months, it'll be worked out monthly. That's how much money I'll end up with. Now, with the effective rate, I'm going to do this with the red pen. I would have R1. I would have my entire interest rate applied, and it would just be calculated once. Actually, we divide it by 1 and we raise it to the power of 1. That's just emphasizing that all of it's been applied on one occasion and it's being applied once. Okay, now how many variables are in this formula? Only one in this equation. So we should be able to solve for this. The right-hand side is very easy. It's just 1 plus I. And the left-hand side, in the blue pen, is a little bit messier, but we can work it out on a calculator. Let's bring up our calculator. Okay, so let's take a look. The left-hand side, as I said, 1 bracket 1 plus 0, 1 over 12 to the power 12. And we get 1,1047. 1,1047. Now we're going to subtract 1 from both sides. And we get I equals 0,1047. Now 0,1047 is actually 10,47%. And that is our effective rate. What that means is that if a bank offers you 10% per annum compounded monthly, that's exactly the same as getting 10,47% once at the end of the year. Notice that the effective rate is higher than the nominal rate. The effective rate is always higher than the nominal rate. Okay, now let's go the other way around. This question says, what annual rate compounded quarterly? Okay, so I'm going to sort of do this in blue. What annual rate compounded quarterly will give the same return as an effective annual rate of 19%. We'll do that in red. Okay, let's do the right-hand side first. So we're going to build an equation here. The right-hand side is really easy. My 1 rand will just become 1 plus 0,19 over 1 to the power of 1. It actually simplifies to 1,19. Right. On the left-hand side, we've got, and we'll do this with the blue pen, my 1 rand, I've got some 1 plus some interest rate. I don't know what that is. That's what I'm trying to find. But whatever it is, I'm going to divide it by 4 because only a quarter of that interest rate gets applied each time. And in the year, the interest will be calculated 4 times. So to the power of 4. Okay, now how many variables in this equation? Absolutely, just 1, right? So what we're going to do to get rid of this power of a 4 is we're going to raise both sides to the power of 1/4. So this becomes to the quarter. Now we're going to subtract 1 from both sides. So we're going to get I over 4 is equal to 1,19 to the quarter minus 1. And the last thing we're going to do is we're going to multiply both sides by 4. Right, so our final answer is going to be 4 lots of 1,19 to the power of a quarter minus 1. And remember, this is going to be a nominal rate, and I'm expecting it to be less than 19%. Let's see what it comes to. Right, so 4 times brackets 1.19 to the power of a quarter minus 1. And we get that number there. Now that number there, 0.177779. Okay, I'm just going to round that off to 0.1778. Okay, before I write it down, I'm actually going to store this number because I want to show you something quite clever. We're going to go Shift, Store, and I'm going to store that number into A. Right, even though I've pressed all clear, if I go recall A, there's that exact answer. Okay, so it's 0.1778. So I equals 0.1778. Which is actually 17.78% per annum. Okay, and that's our nominal rate. Notice that the effective rate of 19% is higher than the nominal rate. The nominal rate is lower than the effective rate. Now, let's just stop and just think about this for a bit. If we, for example, invested 100 Rand, all right, at 19% per annum, that 100 Rand in a year, at the end of the year, we'd get 19%, which is 19 Rand. We would end up with 119 Rand. That's the effective rate, okay? Now, what we're going to do on the calculator, I'm going to show you a clever little trick to show you how to check that this is going to give exactly the same result. Okay, so what we're going to do, we're going to press 100, and we're going to press equals. Now that number, even if I press all clear, that number is stored in answer. There it is. Okay, So now what we're going to do is we're going to take that answer, which has got 100 in it, and we're going to multiply by, in brackets, 1 plus our interest rate. Now our interest rate is in A, that's at 0.1778. We're going to divide it by 4. All right. And so what that's going to do, it's going to grow our 100 Rand by a quarter of 17.78%. And that's how much we'll have after 1 quarter, after 3 months. Now, the clever thing is that because I've pressed equals, this number here of 104 Rand, that is now an answer. When I press equals again, the calculator will redo the calculation, but this time it will add a quarter of 17.78% to 104 Rand, and that's how much I've got after 2 quarters. Now this number is an answer in the calculator's answer memory. So if I press equals again, I will add a quarter of 17.78% to that. After 3 quarters, I'll have that. Now that number is in the memory, so when I press equals one more time after 4 quarters, lo and behold, I have exactly the same. I have 119 Rand, which is what I expected. Okay, so it makes sense. It always makes sense. The cool thing about this method of 1 Rand for 1 year, right, is that we can even convert a nominal rate to another nominal rate. So this says, what annual rate, let's do this with a green pen, what annual rate compounded monthly, okay, so there it is, what annual rate compounded monthly will give the same result as 12% per annum compounded quarterly. Okay, let's have a look. So with the green pen, here's my 1 Rand. It's going to be 1 plus my interest rate divided by 12 to the power of 12. In 1 year, that's what I'll end up with. Okay, with the red pen, we've got 1 Rand. Now we've got 12%, so it's going to be 0.12 over 4, because it's been compounded quarterly. That's actually 3%, all right? And calculated 4 times in a year. Now, you might say, Sir Paul, we've been using 1 Rand for 1 year. What's important about 1 Rand for 1 year? And I'll show you that it doesn't actually matter. If we had 731 Rand here and 731 Rand here, it would not change this equation. Okay, so I'm going to get rid of that. And likewise, if I said, well, let's do it for 10 years, I'm raising this side to the power of 10, and here I'd raise this side to the power of 10. So the number of years and the amount don't make any difference. It just makes it simple just to do 1 Rand for 1 year. Right, now, we've only got one variable here, and we should be able to solve for it. We've got this being raised to the power of 12. So what we're going to do is we're going to raise both sides to the power of 1 over 12. We're going to get 1 plus I over 12. And this is going to be 1. Now this over here is 0.03. That's 3%. And this is to the power of 4. Now we're going to raise this to the power of 1/12. Okay, we've raised both sides to the power of a 12th, which is why that power has disappeared from here. This now becomes 1 plus I over 12. Remember exponents, when we've got a power raised to a power, we multiply them, we actually get 4 over 12, which is the same as a third. So we get 1.03 to the power of a third. All right. Before I go any further, I just want us to ask ourselves, if the interest is being compounded more often, would we expect the interest rate required to be higher or lower? And remember, we talked about this notion of our money earning interest earlier. In fact, we're expecting an answer less than 12%. Because we're compounding more often, monthly, 12 times a year, rather than quarterly, 4 times a year, our I value is actually going to come out to less than 12. Let's see what it's going to be. We're going to subtract 1 from both sides. And then lastly, we're going to multiply both sides by 12. So we actually get I equals 12 into 1.03 to the third minus 1. And let's see what that is. One third minus 1. And there it is. It's actually 11.88%. So 11.88% per annum compounded monthly is exactly the same result as 12% per annum compounded quarterly. Okay, now the next bit of revision before we start our new grade 12 work is the whole idea of a number line. All right, now you may have learned different ways of doing number lines. I'm going to show you two different ways of doing this particular question. So a number line is helpful when we've got multiple withdrawals, deposits, or changing interest rates. Now in this question we've actually got all of those things. Okay, we start off, we deposit 5,000 Rand. So we've drawn a little number line. 3 years later, we withdraw 3,000 Rand. All right, how much will I have 7 years after my initial deposit? Now, the other thing that is happening here is that the interest rate changes. For the first 2 years, the interest rate is compounded monthly. So we put a little 12 in brackets. And it's 12% per annum as well. Okay. And then for the rest of the time, the interest rate is different. All right. Thereafter, it's compounded quarterly, 16% per annum compounded quarterly. So we go I with a little 4 in brackets is 16%. And the question is, how much money do I have at the end here? I'm going to show you two ways of working this out, and I'm going to show you the second way is by far the better way, and we will see why just now. All right. Okay, the first way is just to work along the number line. Now we can't go past any point where there's a change. So I can go straight to T2. So at T2, the amount we will have is 5,000. This is just our normal compound interest formula. 1 plus our interest rate. Now, 12 months per year, 2 years, 24 times the interest will be compounded. Now, we can get that answer, right? And I'll show you, let's get that answer. It's going to be 5,000, 1 plus 0.01. I've done that in my head to the power of 24. It works out to 6348 and 67. 6348 and 67. And while I can write that down over there, I mustn't use that number. I must use the full accuracy that's on the calculator. Right, now from T2 we can't go any further than T3. We can get to T3. Right, what happens now is that this amount of 6348 and 67 gets 1 year's worth of interest. Okay, but remember that this interest that's going to get is actually 16% per annum, but compounded quarterly. So in other words, 4 quarters. Okay, that's how much I'll have at that stage. But remember, at that exact time, I then subtract 3,000 Rand. So let's work out what that's going to be. Okay, so as I said, I'm not going to use the 6348,67. I'm going to use the exact number that's on my calculator here. So now we're going to take that, we're going to times 1 plus 16 divided by 4 is 4% to the power of 4. All right, that's how much is in the account before we withdraw the 3,000, then we withdraw the 3,000. So at T3, after I've withdrawn the 3,000, we've got 4,427 and 5 cents. It rounds to 5 cents. 4,427 and 5. Okay, right. Now the last thing, now we can go from here the whole way to the end. 4 more years. So at T7, we're going to have this amount, 4,427,05. But we're going to put interest on 16% per annum, but compounded quarterly. So we're going to divide by 4. 4 years is actually 16 quarters. And let's see what that comes to. So it's going to be, there it is, times, okay, 1,04 to the power of 16. Okay, and we get 8,291 and 78 cents. 8,291 and 78 cents. Okay, there's our answer. Right. Now, a different way of doing this, which I actually prefer, is to consider each of these investments, and I've put investments in quotation marks because some of them are positive, some of them are negative. Consider them in different accounts. Suppose this amount was in the ABSA account, okay? So let's work out how much it becomes. So basically it's going to be 5,000. That is then going to get 2 years worth of interest, exactly as before. 1% interest, compounded monthly to the 24. And then that amount, we're carrying that the whole way forward now, is then going to get 5 years of this other interest, the red interest, the 4% per quarter, 0.04. It's actually 16 divided by 4, but 5 years, 4 quarters, 20 quarters. Okay. And that's how much that money will actually be worth. All right, let's work that out. That's going to be, okay, that's going to be 5,000, 1.01 to the power of 24 times 1.04 to the power of 20. Okay, and there it is. It's 13,910 and 72. 13,910 and 72. What I'm going to do is I'm going to store that number. Okay, and I'm actually going to store it in A. Just to remind you how we do that, we're going to go Shift, Store, A. All right, that exact number with all its accuracy, I can get back by recall A. There it is. Okay. Right, now let's work out the other amount. Suppose the other amount is with Nedbank. Okay, we're just making up bank names here, but it's in a different bank. And this is an amount of 3,000 Rand, but it's negative. All right, and it's going to be in the account for 1, 2, 3, 4 years. So 1.04, 4 years is power 16 quarters. Right, and so this comes to, okay, negative 3,000 1.04 to the power of 16. Okay, and we get negative 5618 and 94. Right, now, if we take that number and we add it to the amount in A, in other words, the ABSA amount, so we're going to go plus recall A. Right, we get exactly the same answer as before, 8291 and 78. So the total, if we add this and this, final amount is 8291 and 78. Now we will see next time or soon why the second method is actually so much better, so much simpler. All right, but before the next lesson, we want you to practice, try these examples, all right, all these examples, and we will go over them next time. Okay, and we look forward to seeing you then. I think we've done this question. We've done question 8. It's the one we've just done. All right, we look forward to seeing you next time. Have a great day, everyone.